So in 2007, Form B, BC test question number 2, we are not working specifically with vectors here, although we are working with motion um, of an object along a parametric curve. So technically this is a parametrics problem, although vectors and parametrics are very similar to each other. And the first thing that we're asked with this is to find the speed of the object at time t equals 4. Now we are given the first derivative of the x-coordinate and the derivative of the y-coordinate, or dx dt and dy dt. To find speed, we're going to use the formula which we borrow from vectors. That speed is the square root of dx dt quantity squared plus dy dt quantity squared. And so this is a calculator problem, so I'm going to set up the calculator with these derivatives and calculate the speed. And once again, even though we're working with parametrics, we're still going to use the calculator in function mode as opposed to being in parametrics mode, because it's just easier to calculate the things that we need here. Alright, so I'm looking for dx dt as arctangent. So that's the arctangent of t, or x in this case, divided by, and I'm going to need parentheses there, 1 plus x, close parentheses, and I have my first function, the arctan of x over 1 plus x. And for the y, dy dt, it's going to be, sorry, that's just natural log of x squared plus 1, close parentheses, and we're all set there. So I have my two functions in there. Now what I'm going to need next is the square root of vars y vars function y1, that is dx dt quantity squared, plus vars y vars function y2 quantity squared, and that gives me my speed function. Now to calculate that, I need to turn the others off, and I'm going to zoom standard, and I'm looking to calculate this at time t is equal to 4. So that's what in this case would be x equal to 4. So second calc. I don't need the derivative of that because that is already derivatives. I just need the value of that function at x equals 4, and I get 2.912. And that is my speed to three decimal places using the speed function of square root of dx dt quantity squared plus dy dt quantity squared. Next, to find the total distance traveled by the object over the time interval 0 to 4, we're going to use the length of a parametric curve, which is very much related to speed, and that is just the length. That length is equal to the integral from 0 to 4, if I'm looking for the total distance traveled over the time interval from 0 to 4, of the square root of dx dt squared plus dy dt squared dt. So you can see that that's very much related to speed, and what we're really saying is if you take the speed at any one particular time, you multiply that by a small and infinitesimally small change in time. Rate times time will give you distance. You add up all those distances from 0 to 4 and you will get your total distance traveled. So we'll bring back the calculator, and this time I will clear draw, and I'm just going to integrate that function between 0 and 4. And that gives me 6.423. And so we're done with A and B in this, and we'll carry on with part C and D in the next video.